Hyperion Materials Technologies is a global leader in the development and manufacturing of advanced materials, including versatile solutions made with cemented carbide. In this video, we'll explain what cemented carbide is and how the different types of cemented carbide are classified. Cemented carbides are a range of composite materials that consists of hard carbide particles bonded together by a metallic binder, conceptually similar to the way that gravel aggregated with cement binder makes concrete. For cemented carbides, the binder phase that holds the structure together is most often cobalt. There can be one or more hard phases. Primary among these is tungsten carbide, though there are others like tantalum carbide, titanium carbide, or niobium carbide. The tungsten carbide hard phase is generally between 70% and 97% of the total weight of the composite, and its grain size averages between 0.4 and 10 micrometers. Cemented carbides have notable physical and chemical properties, including resistance to stressful conditions like wear, deformation, fracture, corrosion, and oxidation. These properties can be fine-tuned to optimize for different applications. This is done by changing parameters, like the size of the tungsten carbide grains or the amount of cobalt content. By varying the size of tungsten carbide grains and the amount of cobalt, the material can go from extremely hard and resistant to wear, with small tungsten carbide particles and small amount of cobalt, to an exceptionally tough material that is resistant to fracturing, with larger tungsten carbide particles and more cobalt. Leveraging Hyperion's expertise in hard materials, the properties of cemented carbide can be designed to meet the demand of an extensive range of applications. Let's investigate just a few different groups of carbide grades that exhibit particular properties, including straight grades, corrosion-resistant grades, and thermally stable grades. Straight grades contain tungsten carbide and cobalt and are classified according to their cobalt content and tungsten carbide grain size. They have the widest range of strength and toughness of all cemented carbide types, and this is in combination with excellent wear resistance. Corrosion-resistant grades contain cemented carbide grades in which the binder phase has been specifically designed to improve corrosion resistance. This is achieved by alloying the cobalt binder phase with elements such as nickel and chromium, or completely replacing it with a more corrosion-resistant alloy. By doing this, it adapts the cemented carbide to perform well in harsh environments, where other materials would corrode, causing performance to deteriorate. Some examples of corrosion-resistant applications are pump components in drinking water and wastewater applications, recycling shredders that have to crush and shred materials that often contain some amount of liquid, deep-sea drilling in oil and gas, where seals and chokes need to stand up to salt water. Thermally stable grades contain a significant proportion of multiple hard phases that bond with each other, like titanium carbide, tantalum carbide, niobium carbide, together with tungsten carbide and cobalt. The main features of these grades are good thermal stability, low grain growth, and resistance to oxidation. These grains have been designed to provide a good balance of wear resistance and toughness in applications where there is intimate contact with materials that contain iron. Typically, these conditions arise in metal cutting applications. For example, pipe cutting or turning and milling in the creation of automotive parts, like crankshafts, camshafts, or precision gears. All of these groups, straight grades, corrosion-resistant grades, and thermally stable grades, include a variety of subgrades that can be tailored to specific applications. At Hyperion, our focus is on developing next-generation materials, products, and process technologies, including the latest cemented carbides. Our state-of-the-art manufacturing process and global footprint allow us to control all the manufacturing steps from raw material powder to the final carbide product. This allows us to deliver superior manufacturing solutions for various industries, including aerospace, automotive, can making, oil and gas, metal forming, steel manufacturing, hygiene products, and medical and dental tools. Sign up today for a free one-on-one consultation to see how Hyperion Cemented Carbide can help you improve the quality of your wear components or cutting tool applications.